Hello, everybody. This is the ever presumptuous pre-Dr. Bennett, and today I'm going to be doing Khan Academy's MCAT Prep Biomolecules section Enzyme Kinetics questions. There's 10 questions in this problem set, and I'm doing this all live, so let's see how I do. Question number 1. Given that delta G for the reaction S to P, and back, double-sided arrow, is negative in the direction of S to P, reaction equilibrium favors the formation of which substance? So I just remember, I think, getting screamed into my head in biochem, you want delta G to be negative. If delta G is positive, then that means that the free energy of the reactants is less than the free energy of the products. Therefore, you had to put energy into the system. It's less favorable. So I'm going to say that equilibrium favors the formation of P. Hey, and we were right. Okay. Question number 2. How would the addition of a catalyst to the reaction S to P and then back to S affect the difference between the free energies of S and P in their ground states delta G? So we've talked about this before, where the addition of a catalyst is not changing the actual free energy. It's just changing the trip that you take to get there. It's changing the amount of energy that needs to go in there to make the change happen. So delta G is going to stay the same. However, the amount of energy in between those two states might change via a catalyst. So it should be delta G would not change. Yes, and we got it right. All right. Okay, question number 3. For the enzyme catalyzed reaction, E plus S leads to ES leads to E plus P. What equation defines the rate at which ES is formed? Okay, so, and then they give a bunch of definitions for what ES and P mean, which is just the enzyme, substrate, and product. And then when they're combined, it's the enzyme substrate complex. Okay, so which of the following, what equation defines the rate at which ES is formed? So the enzyme and the substrate come together, not necessarily break up, but when they're approaching that transition state. So is it the rate constant times substrate? Is it the inverse rate constant, or sorry, reverse reaction rate constant times substrate? Oh, geez, this is a lot of stuff. I am going to say that okay, so if I was taking the MCAT right now, I'd be answering it the exact same way. I see rate constant and I see substrate concentration, and I know what those two things mean, so I'm going to click that answer. And it's incorrect. So now I'm just going to really quick try to keep on talking while I click all the rest of the answers. Yay, and get the right one. Okay, so the correct selection is the rate constant, K, times the concentration of total enzyme minus the concentration of enzyme substrate complex. So, okay, so that right there, when you have total enzyme minus enzyme substrate, what you're finding from that is the amount of free enzyme available. So it's a rate constant times the free enzyme available times substrate. That makes sense. I can believe that. I can dig that. So let's look at their hints. The rate of a reaction is dependent upon concentration of reactants. The rate is dependent on the concentration of reactants. Okay. The rate of a reaction is equal to the rate constant times the concentration of the reactants. The rate of the reaction is equal to the rate constant, K, times the concentration of the reactants. Okay. As ES is formed, the amount of unbound E and S decreases. Correct. So E total minus ES is equal to the concentration of unbound enzyme. All right, made it that far. The rate at which ES is formed is rate constant times unbound enzyme times substrate concentration. Okay, so that might just be one that I'm going to have to kind of remember, but I could logic my way through that once I saw like what the actual correct answer was. It seems like something that might not really be a huge deal on the MCAT, but it's definitely important to remember for kinetics. Okay, next question. So, oh, here we go. Michaelis-Menten, or Lineweaver-Burke, yeah. How can the Michaelis-Menten constant Km be derived from this Lineweaver-Burke plot? Oh boy. So I remember 1/2 Vmax is the y, or sorry, 1 over Vmax is the y intercept. Ooh, Km. So let's see. That's 1 over substrate concentration is the x-axis. Km is the concentration of substrate at 1/2 Vmax. So maybe there's still a correlation there. I'm gonna go ahead and say that Km is 1 over the x-intercept. Oh no, I am wrong. All right, so the correct answer is Km equals the slope times 1 over the y-intercept. Salcon, please tell me why. Okay, here are the hints. There are 2 ways of deriving Km from a Lineweaver-Burke plot. The x-intercept is equal to negative 1 over Km. The x-intercept is equal to negative 1 over Km. Therefore, Km equals negative 1 over the x-intercept. Well, hang on a second. Oh, but I said 1 over the x-intercept. Oh, well, dang it. Okay, okay, yeah, let's keep reading. The equation of a line is y equals mx plus b. The Michaelis-Menten equation states that, oh god, that's a lot of stuff. Let's go to the end. Okay, Km minus equals the slope times 1 over the y-intercept. The slope times 1 over the y-intercept. I'm just going to have to go back through that, and I would recommend everyone do the exact same. Let my failure be your lesson. Okay, question number 5. If the enzyme catalyzed reaction E plus S yields ES yields E plus P is proceeding at or near the Vmax of the enzyme, what can be deduced about the relative concentrations of S and ES? So if you're at Vmax, then you, I think, have a ton of substrate around, right? Because you need a ton of substrate to bring an enzyme to Vmax, typically. Or, well, I mean, maybe not a ton of substrate, it depends on the enzyme, but typically a lot. So you want a lot. So in the answer choices, I see the substrate is vanishingly low, or the substrate is abundant. So I'm going to go with it's one of the abundance. Then the other half of the answers is the concentration of the enzyme substrate complex is either at its highest or its lowest. So if you're at Vmax, that means you have so much substrate around that almost every single enzyme is bound to a substrate, meaning that ES would be at its highest point. Please. Yes, I got one right. Well, I've gotten 3 right so far. I gotta go better than 50% or else my channel might get shut down by YouTube. Okay, question number 6. What relative values of Km and Kcat would describe an enzyme with a high catalytic efficiency? Okay, so catalytic efficiency. I don't totally remember Kcat, but I remember Km is substrate concentration at 1/2 Vmax. So the lower that is, the more efficient it would be, right? Because that means that it gets to catalytic efficiency quicker, I think. High catalytic efficiency. No. Because if it could do things really quickly, then it would take a long time to reach halfway up to Vmax. So it would take a lot of substrate. So I'm going to say it's one of the low Kms, and I'm just going to go ahead and say low Kcat as well. Oh, I was wrong. High Kcat, right? Please. Yes, awesome. Okay, let's look at the hint so we can figure out what Kcat means. Okay, Kcat, the turnover number, is equal to Vmax over the total enzyme. Okay, so turnover. So Kcat is like another measure of how fast the reaction happens. So catalytic efficiency is described by the specificity constant, which is equal to Kcat over Km. Well, that would have been helpful to know as well. Okay, so catalytic efficiency, remember it's Kcat over Km. So you want high Kcat and low Km if you want to even just think about it mathematically. All right, question number 7. For the enzyme catalyzed reaction, E plus S yields ES yields E plus P, and all that in the reverse. What is the value of Km if the concentration or substrate concentration equals 25 and the initial reaction velocity is half of Vmax? The initial reaction velocity is 1/2 of Vmax. And they want to know what is the value of Km if the concentration of substrate is 25. What is the value of Km if the value of Km is the concentration of substrate at 1/2 Vmax? Oh my God. And one of the answers is 25. Did I just answer it organically like that? Oh, yes, I did. Good work, people. Strong, strong work. Okay. MCAT will try to trick you, but Salcon doesn't. He just puts the answer right in front of your face. Okay. So, question number 8. With respect to binding of regulatory compounds, what properties define an enzyme as being allosteric? Okay, so what properties define an enzyme as being allosteric? Allosteric, that's when you have some other substance binding to another site, right? So binding of regulatory compounds, if it's reversible, non-covalent binding of regulatory compounds, irreversible, I think it's reversible. I'm almost positive it's reversible binding. And then is it covalent or non-covalent? I'm thinking it's non-covalent. That would be a little weird in an in a protein. Yes, and the answer, so what properties define an enzyme as being allosteric is if it has a reversible non-covalent binding site for regulatory compounds. All right, question number 9. Assuming all of the reaction conditions remain constant and that the reaction is allowed to proceed to equilibrium, how would the reaction S yields P and back, I gotta think of a better word for that thing, be affected by the addition of an enzyme catalyst? And that the reaction is allowed to proceed to equilibrium. So you're at equilibrium, then you add a catalyst. I don't think anything would happen. You shouldn't see any kind of increased reaction rate. No? I got that wrong. Stick with me, people, because I'm still talking while I'm trying to click answers. Okay, so the correct answer is increased reaction rate. Well, yeah, okay, because the reactions are still happening if you're at equilibrium. You're not stopping reactions, right? Okay, so hint number 1. Catalysts function by lowering the activation energy of a reaction. Got it? Catalysts do not affect the position of equilibrium. Okay, yeah, I think I knew that. Catalysts do not affect the direction of equilibrium. I think I knew that as well. The reaction... neither increased... Okay, hold on. The reaction SP would proceed at an increased rate with the addition of an enzyme catalyst. But it would just stay at equilibrium, I guess. So you would stay at equilibrium, but you'd be going back and forth faster. Interesting. Okay, question number 10. Molecule X is an enzyme inhibitor that reversibly binds to an enzyme at a site that is distinct from its active site. Molecule X must not be what type of inhibitor? Competitive, non-competitive, uncompetitive, mixed inhibitor. Immediately competitive inhibitor. Yeah, got it right. Okay, so competitive inhibitors, remember, they're competing for that active site with the substrate, and that's why you can overcome them and reach Vmax by just increasing substrate concentration. All right, so I got 1, 2, 3, 4, 5, 6. I just barely scooted north of half, but regardless, strong work as always, gang.